Hey everybody, in this video we're going to talk about what it means to be insoluble and soluble. So, ionic compounds that dissolve in water are considered soluble. So, if you have something that can dissociate and separate into its ions, that means it dissolves and it's soluble. When ionic compounds precipitate out of solution, like in the case of double displacement reactions, those are considered insoluble salts. The ions don't separate from each other because there's a stronger solute to solute attraction than there is a solute for solvent attraction. Some examples of insoluble salts are cadmium sulfide, iron 2 sulfide, lead 2 chromate, and nickel 2 hydroxide. All of these are really pretty colors. You don't always get such a wide variety of color, although you can. Many of your precipitates, like silver chloride and barium sulfate, tend to be just white precipitates. I just wanted to show examples of insoluble salts that actually give you different colors. So, how do I determine whether or not an ionic compound will dissolve in water and dissociate to give me a homogeneous mixture, or in other terms, a solution? I have to follow solubility rules. So here are the rules. Soluble salts typically contain at least one ion from group 1A, which are your alkali metals, nitrates, or acetates. So basically, if you have any of these as a cation, or the top are the cations, or those bottom nitrates and acetates as anions, you're essentially going to have a salt that dissolves in solution. Most other combinations are insoluble. So this can be a little tricky, especially when you look at this. You have, soluble salts, insoluble. What they're trying to say is all these anions, carbonates, sulfides, phosphates, hydroxides, those all tend to be insoluble, right? These are pretty much always soluble. When I look at the halides, like chloride, bromide, and iodide, they're soluble, but they're not soluble when they're combined with these divalent cations. What I mean by divalent, silver is actually not, it's monovalent, it has a charge of +1, but divalent is a +2. So we have silver, lead 2, and mercury 2. So the halides are soluble except if one of these are around. It prefers those over the solvent of water. Sulfates are soluble except if one of these are around. That's why barium sulfate is an insoluble precipitate and will come out of solution. But for a lot of students, this is overwhelming, all these different rules. So if you don't like a ton of memorization, if you want to get 80% out of the 100% of reactions you're going to deal with, I tell students know 2 rules. Group 1A, which are your alkali metals, and I always say, well, ammonium's +1 like your group 1A, and nitrates are always soluble. If you just know those 2 rules, that'll cover 80%, if not more, to help you determine if there is a precipitate, which one is a precipitate, because it won't be the one that has a group 1A cation or a nitrate anion. Now, if you're in a more demanding class, you might not be able to get away with this. So I tell students, okay, you want to learn solubility rules? Let's use acronyms to help us. So what is a useful acronym? Now, this acronym is not, it's not cute, but it does a job. So the acronym I tell students to know is NAG, SAG, Castro Bear, PMS. So what exactly does NAG, SAG, Castro Bear, PMS stand for? Well, let's first go to the NAG. The NAGs are always soluble, no matter what. There are no exceptions. So what does NAG stand for? Nitrates. Nitrates are always soluble. It does not matter what's with it. So if I have a salt like potassium nitrate, and I throw that in water, it's going to dissociate 100% of the time and give me the ions of potassium and nitrate. It doesn't even matter if I have a heavy metal with that. If I have a silver nitrate ionic compound as a solid and I throw that in water, because nitrates prefer the solvent interaction over the solute, it will dissociate and separate. And when it does that, silver is left free floating in solution. So nitrates are always soluble. Acetates are always soluble as well. They're like nitrates. No matter what lattice structure they're in, they're going to break out and dissociate because they prefer to be surrounded by water. And what's the G in NAG? Well, group 1A, the alkali metals. So if you have a group 1A alkali metal in your salt, it's going to dissociate because it prefers to interact with the solvent. And I always tell students, ammonium is kind of like group 1A in the sense that it's a cation with a positive 1 charge. So that takes care of the NAG. The NAGs are always soluble. Nitrates, acetates, group 1. Again, this is going to be at least 85%. If you want more, that's where SAG comes in. Sulfates are soluble too, and we'll see that right here. Soluble. So here we have sulfates. They're soluble, but there are what? They're not soluble with certain exceptions. So these are exceptions down here. Okay? So how can you remember these exceptions? So if one of these are around, sulfate, instead of going with a solvent interaction, prefers to interact with these heavy metals. So how can we remember that? Castrobare. Castrobare stands for the divalent cations, calcium, strontium, and barium. Castrobare. And you can also see that, there's lead too. That's also in it, but that'll make sense with the next portion of the SAG. So to repeat that, in SAG, the sulfate anions are always soluble except castrobare. So a lot of my students enjoy that because that helps them understand, when sulfates will precipitate out. So what's the rest of SAG? Notice the A is lowercase because there's not like an acetate or another type of ion. Okay. So the other solubility rule is group 7A, the halides. And the halides are soluble as well, but just like sulfates, the halides have exceptions. So what exceptions do the halides have? Well, that's the other portion of the NAG-SAG castrobare PMS. PMS stands for lead, mercury, and silver. And we see right here with the halides that the exceptions are lead, mercury, and, oops, sorry, I said lead. Let me redo that. Lead, mercury, and silver. So those are your solubility rules. That'll help you determine whether or not something is soluble. I always tell students, know what's soluble. Everything else is insoluble. NAG, always soluble. What do I mean? Nitrates, acetates, alkali metals, they're always soluble. Doesn't matter what's around. SAG, sulfates, and group 7A are soluble as well, but they do have exceptions. How do we know the exceptions? That's easy. We're going to use castrobare PMS. For sulfates, castrobare, if those ions are around, they're insoluble. Calcium, strontium, barium. For group 7A, chloride, bromide, iodide, the halides, they're soluble with the exceptions of PMS, lead, mercury, and silver. I hope that helps you guys determine in your double displacement precipitation reactions which one would be the insoluble salt. Thanks for your time, and let me know if you have any questions. And NAG-SAG,